I wanted to talk about some different exponent laws. And this is pretty much some review, but it's very important to know what these exponent laws are. So let's get right to it. Now, the first exponent law, and by the way, exponent laws are basically just laws that you can use when you're simplifying exponents. So an example of one, the first one that I'm going to talk about, is the product law. Okay, product law. And what the product law says is that if you have some number to like maybe the m power times some number, the same number, to the n power, that's going to equal x to the m plus n. And that actually makes a lot of sense. Because let's say our number, let's say it was x to the 5 power times x to the 3 power, okay? That would equal x to the 8, right? Okay. And what that would mean is, well, we can write that out, and it actually makes sense, because it will go x times x times x times x times x. That is the same thing as x to the 5th times x times x times x. And as you see, we get a new x that we're multiplying by for every single power. So for example, with 5, we're going to get 5 x's that we're multiplying by each other. And with the 3, we're going to get 3 x's that we're multiplying by each other. And when you multiply these together, we get 8 x's that we're multiplying together, right? And that means that's going to be equal to x to the 8, okay? Okay, so that's the first one, the product law. So as you see, these are basically laws that can help you simplify and solve exponential equations. All right, so let's move on to the next one. And for like a power of a power, what I mean by that is, so power of a power. And what that is it's basically saying that x to the m power to the n power is going to equal x to the m times n. All right, and I'll explain why that works. Okay, well, let's use another example. So let's say it's x to the 5 to the 3 power, okay? Now what that's going to be like, oh, actually, you know what? Let's just say 2 to the 2 power. Just because I don't feel like writing a lot of 5s or a lot of x's today. Okay, so, or a lot of variables today. X, so we know x to the 5th is basically x times x times x times x times x, okay? And when we square this, right, we're basically saying that we're going to take all of these and we're going to multiply them by each other, okay? So whatever number we have now, we're going to be multiplying that number by whatever power you have now. And we have 5 here, all right? But now you're going to have 10 because you're multiplying it by 2. So you can see that whatever power is here, you can multiply it by n to get how many x's you're actually multiplying together. And in this case, it would be x to the 10, because you have 5 x's that you're multiplying by each other in the brackets, and you're squaring that, which means that you're getting 2 of every single x, and you're multiplying them together. So what that would look like is x times 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 x. And that would be 10 x's that you're multiplying by each other, right? Now, if you had 3, the number would be multiplied by 3, and so on. So that's the power of a power rule. All right, let's clear up some space for the new ones. All right, next, the power of a quotient, okay? And what the power of a quotient is going to be is basically saying is, let's say we have two variables, or 2 numbers, right? These represent numbers, x and y, and we're putting it to the power of just m, okay? This some number. that is going to equal, oh, I forgot to write the name, power of a quotient. Power of a quotient. Okay? Okay. And what this is going to equal is x to the m divided by y to the m. Okay? And that actually also makes sense. So let's do another example. Let's say we have x divided by y, and it's to the power of 3. Okay? That's going to be the same thing as x divided by y times x divided by y times x divided by y. All right. And what we get here is x times x times x on the numerator, so x cubed, divided by y times y times y on the denominator, which is y cubed. And you see it works because whatever this power is, all of these x's on everything on the numerator is going to be multiplied by itself 3 times, and everything on the denominator is going to be multiplied by itself 3 times. So that's why both the numerator and the denominator are put to the m power when the whole thing is put to the m power. Okay? So that's the power of a quotient rule. Next, our integral exponent rule, which is basically, well, I'll explain in a sec, let's just write it out. Integral exponent rule basically deals with negative exponents, which is, so x to the minus m, for example, would equal 1 divided by x to the power of m. Okay? So that's basically saying that if you have a negative exponent, it's going to be the same thing, except you're going to take the reciprocal of that. So it's going to be 1 divided by that. And a way to think about it is exponents that are positive, for example, like x to the 3, are basically equal to 1 times x times x times x, right? Which is equal to x cubed. But negative, so if it's negative, then it would be x to the minus 3, which would be 1 divided by x times x times x, which is equal to x to the minus 3, which is equal to 1 over x cubed. Okay? So it's basically saying that if you have a negative exponent, it's going to be 1 divided by x to that exponent where it's positive. All right. Again, let's make some space. Okay. Now we have rational exponents. And okay. Yeah. Okay. So that basically is saying that m divided by x to the n, right, is basically going to be equal to this. Okay. And why is this? Okay, well, let's just think for a second. We're basically saying that this is basically saying x square root n to the power of m is basically saying x to the power of m divided by n. Okay? And when you put x to the power of m, okay, I think I drew something wrong here. Okay. Sorry about that. Sorry, what I meant was x to the power of m divided by n. All right. Sorry. Okay, so what this is saying is x to the power of m divided by n is going to equal to the square root, or the nth root of x to the power of m. And if you don't know, when you have a fraction, the denominator is basically saying whatever root you're square rooting, and the numerator is whatever your power is. So that's why this works. But this is this rule. Okay. This is one of the less common. Well, you might not run into this as much, but it's still very important to know. Now, quotient law is basically saying that if you have some number, quotient law. Actually, you know what? This is a very important rule. You probably will run into this quite a bit. But anyways, quotient law, moving on. It's basically saying that x, let's say just up to m power divided by x to the n power is going to equal x to the m minus n power. Okay? And let's think about that. Well, that's basically saying, let's give an example. Let's say it's x cubed divided by x squared. Okay? That's basically saying x times x times x divided by x times x, right? And you know, if there are 2 on the denominator, they're going to cancel out with 2 of the ones on the numerator. So that's why you subtract. You're basically saying equals just x to the 1 power, which is the same thing as x to the 3 minus 2. So the reason this works is because the numerator is going to be whatever m is, right? And the denominator is going to be whatever n is. So it's going to be, the numerator is going to be x times itself m times, and the denominator is going to be x times itself n times. And when you have the numerator and the denominator, they're going to cancel out until one of them doesn't have any x's left. Either the numerator or the denominator doesn't have any x's left. And that's why the quotient law works. Okay. All right. Next, the power of a product, which is the last one. Power of a product. Okay. Now the power of a product is basically saying that x times y to the m power is going to equal x to the m times y to the m. Okay? And we can imagine this too, right? So let's use an example to prove to ourselves why this works. So let's say it's 3, just as an example. That's going to be the same thing as xy times xy times xy, right? Now, that's basically saying x times x times x times y times y times y, which is equal to x cubed times y cubed, all right? So that's why it works, because each variable is going to be put to that power, and then they're going to be multiplied by each other. So x is going to be put to the third power, y is going to be put to the third power, and they're multiplied together. That's why it looks like this. It's x to the m, y to the m. That pretty much concludes this video for review. Thank you.